Hello, welcome back. Today we're going to be talking about factoring a greatest common factor. By the end of this video, you should be able to factor out a greatest common factor from a polynomial. Let's take a look at our vocabulary word, the greatest common factor. Greatest common factor is the biggest factor that all of our terms of our polynomial have in common. Now we have a couple ways of finding that greatest common factor. One way is to find the greatest common factor is to list all the factors of every term, then select the biggest factor that all the terms have in common. A faster way is to think, what is the biggest expression by which I can divide all the terms of the expression? In other words, we'll think of factoring as division. Either way, and I'm going to show you both ways here in a little bit, we will know we've found the correct greatest common factor if we can distribute our answer and get the original expression, just like when we factored a trinomial. As a quick note, from this point on, I'm going to refer to the greatest common factor as the GCF for short. So we're going to factor out the greatest common factor out of the following polynomial. To do this, we're going to take the long route first to make sure we understand the idea, and then I'm going to go backwards and show you how to work a few examples using the shorter method. Now, the long example, as I mentioned earlier, was for us to list the factor of every single term in our polynomial. So I'm going to start with looking at 4x to the 5th, y to the 7th. Notice 4, I can factor that as 2 and 2, or I can go ahead and look at all of my terms and notice that all of them are divisible by 4. So I'm just going to list this as 4. X to the 5th, I'm going to list as x times x times x times x times x. 1, 2, 3, 4, 5. Y to the 7th, I'm going to list as y times y times y times y. 5, 6, 7. So this is my first term right here. I've listed all of the factors of the first term. Now let's look at the second term, negative 24 x to the 3rd y squared. Negative 24 can be listed as 4, because I already had a 4 on the other one, times negative 6, x to the 3rd, x, 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 y squared, y, y. Plus 16x y to the 6th. So 16, I know I've already got a 4 in my other two terms, so I'm going to factor that as 4 and 4. And I have 1x and 6 y's. So now that I've listed the factors of every single one of my terms, I'm going to find out what the biggest thing all of them is that they have in common. So looking at the coefficient, as we already mentioned, all of them are divisible by 4, or all of them have 4 as a factor. So we know our final answer is going to have a 4. Then we look and we say, what's the largest amount of x's they all have in common? Well, this one has 1x, and so do all of the other ones. So the biggest number of x's I can take out of every single term is a single x. Looking at the y's, I've got 7 y's here, 2 y's here, and 6 y's here. The biggest amount of y's I can take out of all of them is y times y, or y squared. So I'm going to write y times y, or y squared. So this is the greatest common factor of our 3 terms in our polynomial. Now what we do is we list inside parentheses what we have left over after taking that greatest common factor out. So we have x, 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 we have x to the 4th, y, 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 so we have 5 y's, so a y to the 5th. It's a negative 6, and x gives me negative 6x squared. And here I have a 4 and 4 y's, so it's going to be plus 4y to the 4th. So I found out, or factored out, the greatest common factor in this polynomial by writing out all of my x's and all my y's for every single term, and then finding out the biggest number of x's and y's I could take out of each one. Now what I'm going to do is I'm going to check my answer. To check my answer, what I've got to do is I've got to distribute my factored form to make sure that it gives me my original expression back. So let me just show you this way. I'm going to distribute, and I'm going to write the answer above. So 4x y squared times x fourth y to the fifth. We multiply the 4 first, giving us 4. X times x to the fourth gives me x to the fifth. Y squared times y to the fifth, remember you add your exponents, gives me y to the seventh. Minus 4 times negative 6 gives me negative 24. X times x squared is x to the third. There's nothing to multiply y by, so it's just going to be y squared. And then we multiply the 4 times 4x y squared times 4y squared, giving us plus 4 times 4 is 16. X times no x's is just x. Y squared times y to the fourth is y to the sixth. If, after we distribute, we end up with the original expression, then we know that we have factored correctly. And we see that when we distribute, we do get the original expression back. That means that we have indeed factored correctly. Now let me take that exact same example and show you kind of the shortcut method of factoring out the GCF. Notice that first thing you do is you look at every single term inside of your expression and you look at the coefficients, the 4, the 24, and the 16. And you think to yourself, what's the biggest thing I can divide 4, 24, and 16 by? Well, the answer is 4. Then you ask yourself, okay, x fifth, x third, x. What's the biggest amount of x's they all have in common? Well, the answer is just 1x. You can only take 1x out of all of them. Then you ask yourself, look at the y's. What's the biggest amount of y's we can take out of all of them? Well, they all have at least 2 y's, so I can take y squared out of every single term. So, my result is 4x y squared. That's my GCF. Inside of the parentheses, I write what I got when I divided by the GCF. So 4 over 4 is 1. X fifth over x is x to the fourth, because remember you subtract your exponents. 5 minus 1 is 4. Y7 minus 2 gives me y to the fifth. Minus 24 over 4 is 6. X third over x first. 3 minus 1 is 2. Y squared over y squared, those cancel out completely. Plus 16 over 4 is 4. X over x cancels. Y6 over y squared gives me y to the fourth. So this should be our factored form. Notice the factored form is kind of like the opposite of distributing. So when we distribute, we should get back to our original answer. So again, we can distribute to check our answer by taking that 4xy squared and multiplying it into the parentheses by every single term, and we should get 4x to the fifth, y to the seventh, minus 24, x squared times x is x to the third, y squared, plus 4 times 4 is 16. X, there's nothing to multiply x by, so we write it down. Y squared times y to the fourth is y to the sixth. If they match, we know that we have found the correct factored form. Alright, so what I'd like you to do is go ahead and try to factor out the greatest common factor from each of the polynomials below. Now, it might be a good idea to work each one out separately and press play to see the answer of each one, because I'm going to work each one by itself. Alright, for that first example, I'll notice that all of my first terms are divisible again by 4. That's the biggest factor they all have in common. Then I notice my x squared, my x, and my x, the big number of x's they all have in common is just plain old x, and y third, no y's, and y to the fourth. Since the middle term didn't have any y's, they don't have y in common, so my greatest common factor, or my GCF, is 4x. So I write that on the outside of the parentheses, and on the inside of the parentheses I write the result of dividing out or factoring out that 4x. So 4 over 4 is 1. We don't have to write. X squared over x gives me x to the first and y to the third. Minus 16x over 4x is just 4, plus 20 over 4 is 5. X over x cancels, y to the fourth. And there you go. You've written out your answer of factoring out the GCF from this expression. Now, one thing to note, most of the time you'll notice they list your answers from largest exponent to smallest. So you might see this written as x y to the third plus 5y to the fourth minus 4, or you might see the 5y to the fourth listed first. So we're going to take a look at another example. 25a to the fifth b squared plus 10a squared b minus 100a to the third b to the seventh. Notice that all of these terms are divisible by 5 being the largest number they can all be divided by. If we look at it, we have a to the fifth, a squared, a to the third. They all have at least a squared in common. Then we look at it, b squared, b, and b to the seventh. They all have at least b in common. B being the lowest exponent, b to the first. So what we've done, or what we're going to do, is we're going to factor out a 5a squared b. That goes outside of our parentheses. Inside of the parentheses gets the result of factoring out the 5a squared b. So we divide each of our terms by 5a squared b. 25 over 5 is 5. A to the fifth over a squared is a to the third, because 5 minus 2 is 3. B squared over b is b to the first, because 2 minus 1 is 1. Plus 10 over 5 is 2. A squared over a squared cancels out. B squared, or b over b cancels out. Minus 100 over 5 is 20. A third over a squared is 3 minus 2, or just a to the first. And b7 over b is b to the sixth. Now it's a good idea to, and I'm not going to in this example, distribute the 5a squared b back into the parentheses to check that you got your original expression back. So, right here we notice that we've got 16x minus 8, and the biggest thing they're both divisible by is 8. So we factor out the 8, and we're left with 2x minus 8 over 8 is 1. We can check our answer by distributing the 8 back into the parentheses. 8 times 2x is 16x. 8 times 1 is minus 8. So we get 16 minus 8, which is our original expression, so our answer does check out. For this example again, you notice you only have two terms, which makes it a lot easier. And both of our terms in this case is divisible by 3. And also x squared and x, they're both divisible by x. So we get 3x, and 3x squared over 3x is just x, minus 27 over 3 is 9, and the x over x cancels out. We can check our answer by distributing the 3x, giving us 3x squared minus 27x, which is our original expression, so the answer checks out. So I've got some additional examples for you if you'd still like to have a little bit more practice with these. Go ahead and work these out, pressing pause, and when you're ready to see the answer, please press play. For the first example, you'll notice that they're both divisible by the largest number of 2. Also, x squared, x4, they both have at least x squared in common. So we get 2x squared, and we get 3x squared minus 14, and the x squared over x squared cancels. So this should be our factored form, that by distributing 2x squared into the parentheses, giving us 2x squared times 3x squared gives us 6x to the fourth. 2x squared times negative 14 gives us negative 28x squared. Since it matches our original expression, we know that our answer checks out. For this one, probably the simplest of all the ones you're going to see, you'll notice that they're both divisible by 3. So we get 3, and then we get 5 minus y. If we distribute that back out, we get 15 minus 3y, which does indeed check. And for the last example, you'll notice that all of these terms are divisible by 2 in this case. It's the biggest number we can divide 6, 16, and 8 by. You also notice they have at least an x in common and at least a y in common. So we get 2xy, and beside the parentheses, 6 over 2 is 3, x over x cancels, we get y to the fourth left over, minus 16 over 2 is 8, x third over x gives me x squared, y over y cancels out, minus 8 over 2 is 4, x squared over x gives me x, y4 over y gives me y to the third. So this should be our final answer. We can always check that by distributing 2x squared, or 2xy times 3y to the fourth, gives us 6, x times nothing is x, y times y to the fourth is y to the fifth, minus 2xy times negative 8x squared gives us negative 16, x times x squared is x to the third, and we get a y, minus 2xy times negative 4x y to the third gives me negative 8x squared y to the fourth, because x times x is x squared, and y times y to the third is y to the fourth. If our expressions check out or match, then we know we found the correct factored form. And we notice that our checked out answer matches the original expression, so this means that we did factor correctly.